In the previous video, I compared list to some other built-in data types in Python. In this video, I want to compare list to a data type that comes from the NumPy library. So we have to import the NumPy library. I'm going to say import NumPy as NP. And this is like saying NP is the abbreviation we're going to use to refer to this library for the rest of the notebook. And that's the conventional way to refer to NumPy, so we should always use this. Even though it's not required, it's the way that NumPy is always referred to. So we're going to follow this convention in Math 10. And let's make a list. I'll call it my list equals, how about 3141? And just like I could convert this into a tuple by wrapping it inside tuple, I can convert it into a NumPy array by wrapping it inside of np.array. So this is saying from the NumPy library, we're going to make an array. And then I'll put my list in here. And let me call this my array. And so if I ask what's the type of my array, it says numpy.nd array. ND stands for n-dimensional, I believe, because you're supposed to think that it might not just be a list, it might be something more like a matrix or even a higher dimensional thing. So what is an advantage of a NumPy array over a list? Well, let's try to add 2 to every element in my list. So we could do this using list comprehension. Like we could say x plus 2 for x in my list. Okay, that's fine. We could do the exact same thing for my array, for x in my array. Okay, notice that this one also produces a list. And that's because we're using list comprehension here, which we can tell because we have these square brackets on the outside. So, okay, well, I haven't said what an advantage is of my array versus my list yet. Let me show another way we could make this same thing. Only difference is what I'm about to do is going to produce another NumPy array. It's not going to produce a list. I can just do my array plus 2. Okay, and this, it's the exact same numbers here. Only difference is this one, it's still a NumPy array, whereas here we converted it into a list. You could try doing the same thing with my list. Okay, but that doesn't work. So this sort of built-in functionality is really helpful with NumPy arrays. Another example, let me make a series of random integers using NumPy. So here's how to do this. I'm going to say np.random, and in general, it's difficult to make random things on a computer, so that's why this code is going to be a little difficult. So here I'm making what's called a random number generator. Like, let's check what this is. Okay, this is something, it's built into the NumPy library, and here it's getting called a generator. Okay, RNG stands for random number generator. And from this, I can make random integers. Like, for example, I can say RNG.integers, and then if I say, for example, 0, 10, size equals 20, so notice that this again is making a NumPy array, and it's giving me 20 random integers between 0 and 10. Okay, and just like is usually the convention in Python, it does not include the right endpoint. So let me define a larger array of random integers called ARR. And now instead of being size equals 20, let me say size equals about 1,000,000. And let's time how long it takes to add 2 to all of the elements in ARR. Okay, and while we're waiting for that, I'll start making a list out of this. So let me say my list equals list ARR. Okay, so this is very fast. It's about 1 millisecond, I think. So it's about 1,000 microseconds. So about 1,000 millionths of a second. So it's about 1,000th of a second. And let's convert this thing into a list. And if I want to see just like what are the first 10 objects inside of this, here are the first 10. And let's time how long it takes. So time it x plus 2 for x in my list. And let's see how long this takes. And so this took 435 microseconds. And remember, this one took less than 1 microsecond. So you can see that this is hundreds of times slower, even for this very simple operation of adding 2. And the underlying reason for that is that a lot of these basic arithmetic and even not so basic operations in NumPy are what are called vectorized, and it is possible for Python or underlying maybe the C programming language to make a computation using a NumPy array much faster than it can using the list data type in Python. So that extra efficiency for these sort of arithmetic operations, that extra speed for NumPy arrays, that's one of the big advantages of a NumPy array over a list.